So this is problem 5b from the review about comparing the speed of a brick drop from h with one drop from 2h. So the key here is we are changing from gravitational potential energy at the first height to kinetic energy when it makes contact with the ground. And then we'll also do that for the second height. mgh2 equals mv2 squared over 2. We want to talk about speeds. We're talking about velocity. So if we get rid of the mass and we solve for v, see v1 equals the square root of 2gh1 and v2 equals the square root of 2gh2. Great, fine. But the thing we want to get to here with this one is we want v2 to be equal to something times v1. That'll tell us the ratio of the speeds between the two things, which means we need v2 to be equal to some number or something times the square root of 2gh1. We don't have that. We have the square root of 2gh2, but we do know that h2 is equal to 2 times h1. So we actually go back in here and substitute that in. v2 is equal to the square root of 2g times 2h1. Okay. How can we handle that now? Well, a lot of you might jump to the conclusion of, oh, let's do 2 times 2 is 4, pulled out of the radical, but that's not what we want. We want the square root of 2gh1 to still be underneath the radical. We just want it to be multiplied by something. So let's just move things around a little bit. If we have 2gh1, and then let's multiply that by 2 underneath the radical. That way we see that here. Okay, well, we've got v1 underneath the radical, but we also have this 2. How do we deal with that? Well, remember your properties from math. We can make this the square root of 2 times the square root of 2gh1. Because we can pull that 2 out of the radical as long as we keep it underneath a radical. So from there, we just do the fact that, well, we know the fact that square root of 2gh1 is v1, so that means that v2 is equal to the square root of 2 times v1. So that square root of 2 is our factor that we're changing it by. And the reason why it's a square root is because of the velocity is determined by a radical relationship, a root relationship between the two variables, not a linear or quadratic relationship like we see with some other variables. So for instance, if we had raised the height by 9 times, so if we did 9 times h1, that would mean that the velocity would be 3 times v1. If we'd gone up by a factor of 16 h1, so we have to go up 16 times the height to get 4 times the velocity because of that root relationship right there. Okay. So hopefully that clears up any questions on that problem. Again, if you have any other things, let me know.